I'm here with Dr. Romano to do a comparison type problem for the DAT.
Hi, I'm Dr. Romano, a professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products, as well as the author of the DAT Destroyer. I'm going to work a new type of question with you that has suddenly began to appear on the exam about a couple of months ago, and that's called the comparison type of question. So I'm going to work this with Professor Blois, but come around and let me show you what we're going to be up against. For this type of question, we're going to choose A if quantity A is larger. We're going to choose B if quantity B is larger. If the two quantities are equal, we're going to choose C. And if the relationship cannot be determined, we're going to choose D. So let's come over to the board, and I'd like to introduce you to Professor Blois. Professor Blois was my instructor in statistics as well as math in college, and he's going to work a problem with us on how to do these new type of questions. So, Professor, I'll leave the board to you.
Hi, Professor Blois here, and let's read the question together. Here we have two defined quantities, quantity A and quantity B. Quantity A, the number of ways of choosing a committee of 5 out of 12 people. Quantity B, the number of ways of choosing a committee of 7 out of 12 people. Okay, now, this is a problem that's going to involve combinations. And we know it's combinations because order doesn't count. It even explicitly says order does not matter. So we know we're going to use the combination formula, which is this. NCR is equal to n factorial over r factorial over n minus r factorial. Now, it's not even necessary to add the clause order does not matter because there are a few key words in the question that cue you into the fact that order does not matter, that we're looking for combination. What are those key words? Choosing. Okay, we're choosing. And committee. Committee is not an ordered group. It's just a group where order does not matter. It's just a group of people. So these two words are sort of cue you into the fact that we're using combinations, that order doesn't count. So let's figure out what quantity A is. Okay, quantity A is going to be, we're taking 12 things, we're choosing 5 things out of 12. And that's going to lead to the expression 12 factorial divided by 5 factorial times n minus r factorial. 12 minus 5 is equal to 7 factorial. Let's not figure this out. We could figure this out. It'll take some time. But let's just figure out find the expression for quantity B. We'll see that we'll save a little bit of time. For quantity B, we're choosing 7 people out of a total of 12. So the expression is 12C7. That's 12 factorial over the number of things we're choosing is 7. So it's 7 factorial times 12 minus 7 factorial, which is 5 factorial. Well, take a look at these two expressions. They're exactly the same. Choosing 5 people out of a committee of 5 out of 12 is the same number of ways I can choose a committee of 7 out of 12. So there's no need to go any further. They're both the same quantity. So according to the original statement of the problem, we're going to choose C. And that's how to do this problem.
Okay, Professor, before I end the question, can you just define for the students what N and R
yes.
are? I just noticed that you put that up, and there might be a few kids that are a little shaky. What exactly is N defined as an R?
N is the total number of objects from which things are going to be chosen, and R is a subset of those objects that are going to be chosen. So you're choosing R things out of a total of N things. So in other words, 5 students out of a total of 12 students, 7 students out of a total of 12 students.
And it's safe to assume N is always larger than R.
Oh, N will always be, right, at least as long, yeah. Right.
Understood. All right, I hope this gives you an idea. This is a really good problem because I'm not sure many people were expecting these were going to be equal. I thought it was a great problem. Yeah. Okay, guys, we'll see you in study group, and hopefully one day you'll get a chance to meet Professor Blois. Bye-bye.